In this example, we're going to find the derivative of 1 over 10t minus 4. And this is a chain rule problem, and I'm going to do it in three slightly different kinds of notation. I'll use the z notation, the so-called fill the box notation, and finally the in your head notation. And I wouldn't recommend that most students do it in three different ways or even two different ways, but you can pick whichever notation you like best, and it might be useful still to at least see one of the other notations. It might help you see how the different pieces get treated differently in the chain rule. Okay, so let's do the z notation first, and I'll start by reminding you what the chain rule says in z notation. So dy over dt equals dy over dz times dz over dt. In words, this means the derivative of y with respect to a variable t equals the derivative of y with respect to z times the derivative of z with respect to t. Okay, I'll also on this screen remind you what the formula was that we're taking the derivative of. So it's y equals 1 over 10t minus 4. Okay, so our first step is to identify what z can be. It's not given to us. We have to figure it out. Usually I say it's the inside of a function. In the case of a fraction like this, the bottom part is typically the inside, so-called inside part. So in any case, that is the part I will label as z. So z equals 10t minus 4. And then given that, I can write y in a simpler way. Y is equal to 1 over z. And this kind of shows you the purpose of the chain rule. It breaks a more complicated formula up into two simpler formulas. And if you look at these formulas, each of them I know how to take the derivative of. There's one last thing to say about 1 over z. If you're going to take the derivative of that, you should definitely think of it as a power. So you need to, at least in your head or maybe on your paper, rewrite it as z to the negative 1. Okay, so now I should find the derivative of these formulas, 10t minus 4 and z to the negative 1. Let's start with the second one. dy over dz, you should bring the power down in front. The negative 1 power comes down in front. It's a negative. And then you subtract 1 from that power. So you're left with z to the negative 2. Okay, and now let's take the derivative of the formula for z. So the derivative of 10t minus 4. And that's just 10. That's the slope of the line 10t minus 4. Or you can use the derivative rules to find out that it's 10. Okay, so those last two formulas we should now multiply together because that's what the chain rule says. So it'll be negative z to the negative 2 times 10. And that's done. We're done there with the derivatives, but our final step should be to rewrite it so that we use the original letters, namely t, and not the letter z that we made up. So I'm going to replace z with 10t minus 4. And there's my final answer, negative 10t minus 4 to the negative 2 times 10. Okay, so now let's do the same thing, but using what I will call the box notation. So in this case, I will write a rule for a derivative with a box in place of the usual letter x, and then we will fill that by putting a different formula inside of that box. So the usual rule that I'm going to use is 1 over x, but I will write it with a box. So the derivative of, and of course it's a power rule. So the derivative of a power, box to the n comes down in front, and then we subtract 1 from that power, and then, and this is what makes it the chain rule, we multiply by the derivative of whatever is inside that box. So in this case, of course, that power is negative 1. So the derivative of box to the negative 1 equals negative box to the negative 2 times box prime, meaning I still need to take that derivative. Okay, so I'm going to put stuff inside of those boxes. The same thing will go inside of each box. And I need a little more room, so let me expand the box to fit. And of course, what I'm going to put inside there is, as we know from the previous notation, 10t minus 4. So the derivative of 10t minus 4 to the negative 1 equals negative 10t minus 4 to the negative 2 times 10t minus 4 prime. Okay, so the last step is to finish that last prime. As long as you have a prime there, that means you haven't taken the derivative yet. So I need to, and I will rewrite it without the boxes as well. So the first part I'll use parentheses, negative 10t minus 4 to the negative 2, and then the last part I take that derivative and it becomes 10 instead of 10t minus 4. Okay, so let's do it one more time, and this time I'll use what I call the in your head notation. And what I mean by that is that instead of writing down either boxes or z's, you just kind of remind yourself when you're looking at the formula, this part is inside and this part is outside. And then you say something like, take the derivative of the outside, don't change the inside, and then multiply by the derivative of the inside. And I usually color code this, at least when I'm showing students. Maybe once somebody's good at it, they don't need the colors. But I will color the derivative of the outside part red, and the derivative of the, don't change the inside blue, and then I will multiply by the derivative of the inside. That'll be in green. Okay, so the first step is to identify, just like in the other parts, kind of what I mean by the inside and the outside. So if the formula is 1 over 10t minus 4, I will color this. The outside is the 1 over part, which is the, maybe that's an easier way to see it, is to think about the power of negative 1, which after all I need to do for the power rule too. So if I rewrite that as to the negative 1, then the outside part is the parentheses to the negative 1, and the inside part is 10t minus 4. So the derivative of the outside means the negative 1 should come down in front, and then we should subtract 1 from that power. So negative, parentheses, and then parentheses to the negative 2. So that's the derivative of the outside. I should not change the inside, so I should just rewrite, like copy and paste, 10t minus 4 inside. And then finally we should multiply by the derivative of the inside. And I pretty much always break that out as a separate step. Obviously in this case, especially since we've looked at it twice, you probably know what that derivative will be, but usually I break it into a separate step, and so I would write, if a separate step, I would write it as 10t minus 4 prime, meaning I haven't yet taken that derivative. And then my final step would be to write it one more time, negative 10t minus 4 to the negative 2, and then times 10, where that last 10 is just from the derivative of the inside.